Again, welcome to week 13. Good afternoon, everybody. We almost finished with the semester. Again, this is our week 13. Next week, week 14, we have one assignment, which is the final exams. And also, we're going to have a discussion thread. Then, week 15, we're going to have only discussion thread for the section. So, again, this is our week 13. And again, thank you for the hard work everybody did last week for the week 12 assignment. And we have our final Weka assignment for week 13. So I will go through the assignment. Also, last week is part 1 of the Weka, and this week is part 2 of the Weka. So the first thing I'm going to do now is to go through the week 13 folder. So as we can see, week 13, as usual, we have discussion thread. We should make sure we post our initial discussion thread on Wednesday, January 31st, and before the day is over, 11:59 p.m. That should be our initial discussion thread. As usual, again, if your initial discussion is thread is late, I normally deduct 5%. Which we discussed already, 5% late per day. Also, we have quiz number 11, which will be our last quiz for the section. Then we have assignment number 10, which also will be our last assignment for the section. And this assignment is again Weka Lab assignment part 2. So I'll go through the assignment in a second. Also, in our discussion thread, we are going to discuss about clustering algorithm, which is one of the data analysis or data mining techniques, cluster algorithms. And I'm going to give a lectures on it today. And also I have a reading assignment for it, since we are going to discuss it in the discussion thread. I have a lecture slides for it, and also a link to cluster algorithm information notes lectures. So we have quiz 11, last quiz, and also assignment 10, which is our last assignment. So in this assignment, we're going to use the Weka program again. And this time we are going to use 4 different algorithms. So almost the steps is the same as last week's step, only this time we are using different algorithm and also different data sets. So here they say we should use the zoo data. Also, when you go down, I have all the data set for the assignment. We have the zoo, Weka file, the breast tumor, and also body fat data set. So in the first assignment, we are going to use the zoo data, and we are going to use the 1R algorithm, which is a classification, and also decision tree table, which is classification also. Last week we used it also, and this is a rule-based algorithm classification. Then we're going to use a C4.5. C4.5 is the same as the J48. Weka call it J48. In our theory lectures, almost every textbook you see, the decision tree is C4.5. No, that's normally the name, but Weka call it J48. And also we're going to use a K-means, which is cluster algorithm, simple K-means. The concept of cluster algorithm is that we are going to find similarity in our data, and the number of clusters, if we have only one similar, all the data are similar, then we have only one cluster. If we have 2 or more similar, then we have 2 or more clusters. So K-means means the K will be the number of clusters we want. So we're going to use this 4 algorithm on a zoo data. Then we are going to discuss about the output. So here, for example, we said try use reduce error premium, and that's for the J48 or the C4.5, and see if it will change the model. What we mean by changing the model, we mean the accuracy or the precision will be better. Then also for the K-means, They say first time use 10 as the k value, number of process 10. Then it adjusts as you want. Then explain the differences based on the number of k's, the output based on the number of clusters we have. Then question number 2, we are going to use the breast tumor data, and we are going to perform linear regression, M5, regression 3, k-means cross-story again. Then we're going to answer the following. Again, please make sure you answer the question. Using the system or the Weka application is easy. It's a step by step. Most importantly, understand what you are doing. Why do you select so amount of training set? Why do you select so amount of test set? Why do you know also the output? What is the performance of the algorithm? Misclassification, errors, or etc. So the questions here, please try to answer them. Then the last section also, we're going to use k-means cluster algorithm again, this time on the arrays data. I did not post the arrays data here because we used it last week. And also, let me go back. Also, when you download, as I said earlier, after we download the Weka program, it comes with a data file. The data file consists of all the files I'm using or we are going to use in this. So all the files that I have here, this is the arrays data set. So the arrays data set again is inside the week 12 folder. So I don't want to add it in week 13 folder. But all the data sets we are using, they all came with the Weka application. So when you download and you install the Weka, go through the directory that you install your Weka, you should see data folder. When you open the data folder, you see all these data is there. So that's the assignment. Again, the steps, everything is the same as last week. Only this time we are doing different analysis, different data sets. And as we said earlier with Weka, we have 3 steps. First, get your data. Second, analyze your data. Then thirdly, interpret your results. And then when we get the data, we have to do data preparation. So again, with Weka, get your data and prepare it, analyze it, then see your result, interpret your result. So now I'll go through the Weka one more time. So last week I posted the lectures on Weka, and I don't want to do the same lectures this week. So what I'm going to do now is just a lab work. Most of you know this already, but just again, go through one more time. So when we start our Weka program, again, we can see the pre-process. This is where we prepare our data. Example would be like discretization, or I would say, or normalizing our data, transforming the data. This, in general, this is the data preparation process. When we have data, there's 2 things we have to worry about. Is the number of attributes too much that maybe we need to reduce? Or the number of records, the instance, is it too much? We need to reduce it. If these problems are answered, then the next thing, let's look for errors in the data. Do we have a duplicate in the records and missing values? Then we have to solve all these problems. And I think we had a lectures on this and the data preparation a few weeks ago. So after the pre-processing, the next step is where we do our main data analysis or data mining tasks. Other classify. In classify, we have to have 2 types of data set, one for the training to build a model, and one is the test set to test the model. Then cross-story, we don't need any class label or anything. We just want to find the similarities in our data set. Most of the algorithms use what we call the distance measurement algorithm, like Euclidean distance, Manhattan distance, Minkowski distance, a lot of algorithms. association, which is associate. Our goal is we want to find actually that's why it's called association. We generate association rules, which means we are going to find if there's any association or relationship between two or more values or attributes. I'll use the term values. Let's say, for example, if I buy bread, what is the chance of buying maybe peanut butter or something? Or if I buy a computer, what's the chance of buying maybe printer or something? So association, very important also. Then select attributes and also visualize. So here I'll go through the pre-process. I'll click on pre-process. Then first step, I'm going to click on open file to open any file I can think of. Let's say I'm going to open the breast cancer. So when I open it, I can see that Weka tells me all the attributes in the files. I have 10 attributes in the file. For example, I have the age. This file is a breast cancer data set. So say by patients that have a breast cancer, their age, whether they have menopause, the tumor size, etc. And our last attribute is very important. That is the class. And when I click on the class, I can look at the select attribute section, and it will tell me what kind of values we can have here. So here we have two options. I'll say yes or no, but here we are using the term no occurrence event or there's a occurrence event. So with the label, this is our training set. We have 201 no occurrence events, and we have 85 occurrence events. Now I can click any one. Let's try the age. Same thing here. We can see that the age given in a discrete level. So if your age between 10 to 19, we have this represent 1. And here we have 0 count. Let's say between 50 to 59, we have 96. So the weight is 96. So again, starting this, open the file here, we can see the Weka again gave us the values and also the attributes in our data set. You can select any attribute and you will see the content. So when I select node curves, the labels are either yes or no. We are 56 years, 222 no. I can see the sum of all my data sets. So the instances is 286, which means I have 286 records. And the relation means the file name or the table name in the breast cancer. So after we study our data set, you can see that when the label, in this case, the attribute node curves, the type is nominal. We cannot find average of a nominal value. So we only find the mode or the count. Now let's select age. Age also in this case is nominal because they set the age as a label. Between 10 to 19 is 1, 20 to 29. I want us to see if we can get in quantity. So almost all the data types are nominal. Okay, in this case, all our data sets are nominal. But what I mean is that if, for example, the data set is a quantitative or a numeric value, you will see that the system will find the mean, media, and also to find the standard deviation for us. Because with a nominal data, we can't find the mean or media, or the only thing is the mode or the count. So the next thing I'm going to do now is classification. So I'll click on classified. And then I'll click choose. And here I have to select what algorithm I'm going to use. So we can see here classifiers, we have different algorithms. Probability algorithms, which is the bias, we have at least 4 active here. Functions like neural network, logistic, support vector machines, SNO. Neural network is the multi-layer perceptron, etc. So we also have the logistic. And the algorithms keep going. So we select which one we want to use. Now, one thing also in the pre-processing, I only explain our data set, but also we can do data preparation here. So in Weka, data preparation is called a filter. So here we can see filter. I'll click choose and then filters. Now I have supervised or unsupervised, hard filter, multi-filter, all filter, multi-filter, etc. Now when I click on supervised, I'll get 2 options. Do I want to, my concern is the attributes or the records. For example, if I want to reduce the number of records, I'll go to instances. If I want to work on the attributes, maybe combine 2 or more attributes, then I'll go to attributes. And here we have different algorithms. Maybe some of us know this in the theory, discretization. Discretize is the most common data preparation method that we do a lot. So discretization means, again, trying to arrange our data, the values in a label form. So I didn't choose anyone, but again, let's just choose I don't know, anyone. Let's choose the discretize. And then when I click discretize, I'm going to click on apply here. And let's see what will happen. Right now, I know I have 10. I have 10 record, 10 attributes, and we can see nothing changes. Now let's do the instance. I'm going to select any algorithm here. Let's resample it. See if it's going to reduce our number of instances from 286 to lesser. Of course, we cannot increase. What we can do is by decreasing. And when I apply, nothing changes. So we can try another one. Stratified, remove folds. Okay, so this works. You can see that when we do the stratify remove folds, it reduces the instances from 286 to only 29 for us to use. And I can click. So maybe let's play with that and see. So here I'm going to select a training set and also do the percentage. 66 for training set, which means the rest will be for test set. And I'll run it. So when I run it, this is the result that I got. Correctly classified instance 7, incorrectly classified is 3. So this is not too good. And when we look at the confusion matrix, we can see that we have 7 and 3, which means 7 A and A, which means no 7 is good. 3 is supposed to be at B because it's reoccurrence event, but it's at A. So that's why we're getting correctly classified 3 here. So again, we can do our data analysis using Weka, using different algorithms. But again, this is just an example that I want to go through one more time before I start the lectures on and the clustering algorithm. So I'm going to end here. And I'm going to start cluster algorithm. So again, the reason I'm doing this is not a data mining class. This is data analysis and visualization. And data analysis, as I said earlier, is the same as data mining, same concept. But we are not spending too much effort to go detail on all the data mining algorithms. So in this section, I'm just going to discuss about the concept of cluster algorithm. And there's next class that will be coming on. I think I'm not sure about the number, but we have a data mining class, and that class will be more detailed in data mining. The university offer in this program data mining classes offered, and those of you taking PhD, even there's a big data analysis where they use like scalar, map, reduce, the concept of big data analysis are discussed over there. So in this section, we're going to discuss about the basic concept of cluster analysis, then what is partitioner method, higher ranking method, density-based, grade-based method. Those are the four major different methods of clustering, then evaluation. So what is cluster algorithm? In machine learning, we use the term unsupervised learning. Actually, we can see the term here. Because the reason why cluster algorithm is called unsupervised learning is because we don't have a training level, like a class level. Like for example, the breast cancer data set, we saw that we have a attribute name class, and that class can say, okay, reoccurrence of event or non-reoccurrence of event. Or I may have a data set saying this is a breast cancer. The class is patient have it, yes or no. So now I'm going to use the training data to build a model. Then I'll use the model to predict a future data set without or classified data set without the class label. But in cluster algorithm, we have a data. There's no class label. So our goal is that we are going to group the data into clusters. And this grouping will be based on the similarity of the data. So the data, if we have two or more values that are similar, we group them together as one cluster. If they are similar, they are not the same, we group them in different clusters. So that's the whole concept. So yeah, we say cluster is a collection of data objects. So similar or related to one another, they will be in the same group. Dissimilar to the object will be in different groups. So cluster analysis, the goal is that we want to find the similarities between data according to some characteristics found in the data and grouping similar data objects into clusters. Sometimes we use the term unsupervised learning, which is no predefined classes. We don't have no training sets. So clustering for data understanding application, we have so many applications. So example given here is biology. Example would be taxonomy of living things, and based on the kingdom, living things, classes, family orders. Then information retrieval, document clustering. We are going to group all the documents that have similar content, political news together, sports news or documents together in different. So we are not going to group the sports news and political news together as one cluster. They will be separate. So information retrieval, document clustering. Land use also the same concept. We can identify areas of similar land use. In this case, in an health observation database. Marketing also, we can group customers and based on maybe their income or their purchasing pattern, etc. So help marketers discover distinct groups in their customer bases and then use this knowledge to develop targeted marketing products. City planning, identify groups of houses according to their house type, the value, geographical location. So these are again different types of clustering applications. Now, summarization, pre-processing for clustering, we can use what we call the PCA, that's principal component analysis. The goal of PCA is to try to, in case we have two or more attributes that the content are similar, what we do is that we can drop one or two attributes and keep only one. Example would be, I have date of birth and age. If PCA thought they are the same or they have the same, one can be dropped. So the goal of PCA is trying to reduce the attributes. We also have this association analysis, trying to find a relationship between two or more attributes. Compression, we know that, for example, image processing, we do file compression. Also finding the K nearest neighbors and localizing search to one or more number of clusters. We can also use clusters as pre-processing for outline data set, data that is maybe too small, too large compared to majority of the values of the data. So what is good clustering? I would say the high intra-class similarity. If they are the same, they are very, very, or if they are not the same, low inter-class similarity. This is cohesive within clusters, and distinctive between clusters. So the quality of clustering method can depend on again, everything based on similarity measures. And we do this normally using the distance measures. So this is where we say the definition of distance functions are usually rather different for interval scale, Boolean, categorical, ordinal ratio, and vector variables. So measuring the quality of clustering, most of the time we try to measure the similarity and also the dissimilarity. And we are going to use the distance measurement. Now, these are the four major cluster analysis. We can use the partitioning criteria. So here means we are partitioning all the data set. I can partition it to 2 or 3, any amount based on what the similarities among them. So we can have a single level or hierarchy, but most common is the hierarchy partition, which is multi-level hierarchy partition. It's desirable. Also, sometimes we may have separation of clusters. So we start with one cluster, then based on the similarity, we're going to separate it. Then similarity measure, most of the time we, as we said earlier, using the distance base. For example, Euclidean distance, Manhattan. Requirement and challenge with cluster algorithm is almost the same as classification. Scalability is a very big issue. How large the data sets are. Here also, ability to deal with different data types, same problem with almost every data mining algorithms. Then constraint-based clustering. This means user must give some input as their constraint boundary. To interpret, same as some of the classification algorithm, interpretation of the results and the output of the algorithm, and usability. Ability to deal with noisy data, which make the system, the algorithm more robust. Some of the cluster algorithms have this problem also. But one of the best classification algorithm that works very good with noisy data is the neural networking and also support vector machine. So major cluster approaches, as we said, partitioning approach. Here we use k-means or k-measures or clearance. Hierarchy approach, then we have Diana, Agnes, Vic, and Chameleon. Those are some of the algorithms. Density-based approach, DVSs, optics, and then crew. Density approach concept is that if we have a lot of data sets and the density is very high, then we group everything as one. And where the density is low, there's more space, then we separate. Then we also have a grade-based approach. So we're going to end somewhere here. I don't want to go details on the algorithm. So in the slides, we'll go more detail what is partition method, hierarchy, density based, and grade based. But I'm going to end here as this course is not really a data mining course, but just for us to get a concept. So again, about the assignment, I'll go back to the, again, we have a Weka lab work and we have 4 questions. So again, the assignment are due on Sunday, August 4th. And if you have any question about the assignment, you can either send an email or you can also give me a call at 917-627-0024. So again, thank you very much and wish everyone the best.